The German sniper nestled deeper into his snow-covered position along the frozen river crossing near the Dutch-German border, his breath forming small clouds that he carefully controlled to avoid revealing his location. Through his scope, he had watched Allied soldiers for weeks during the brutal winter of 1945, learning to predict their movements and identify the moments when cold-numbed hands fumbled with weapons and equipment. He had seen American troops abandon firing positions when their rifles jammed from ice buildup, watched British soldiers struggle with frozen bolt actions that refused to cycle properly, observed how extreme cold degraded the combat effectiveness of even well-trained units as equipment failed and men lost dexterity in their fingers. But the Canadian troops who had recently moved into his sector behaved differently, maintaining rates of fire that seemed impossible given the temperature and continuing to operate weapons that by all logic should have frozen into uselessness. His after-action report filed days later would note this anomaly with professional bewilderment, describing enemy soldiers who seemed immune to the mechanical failures that cold imposed on other formations, and questioning what modifications or techniques allowed them to maintain such effectiveness in conditions that reduced other Allied units to near helplessness. The winter of 1944 to 1945 stands as one of the coldest on record in northwestern Europe, temperatures plunging to levels that transformed every aspect of military operations and created an environment where survival itself required constant attention and effort. The cold affected everything from vehicle engines that refused to start to radio batteries that died within minutes of exposure, from rations that froze solid and required thawing before consumption to medical supplies that became useless when frozen. But perhaps no aspect of winter warfare proved more critical and problematic than the effect of extreme cold on infantry weapons, the rifles and machine guns that represented a soldier's primary means of fighting and surviving combat. Modern firearms are precision instruments with tight tolerances and moving parts that must function smoothly for the weapon to fire, chamber the next round, and continue operating through sustained use. Cold weather attacks every aspect of this mechanical system through multiple pathways, metal contracting and creating even tighter tolerances that increase friction, lubricants thickening into sticky sludge that impedes rather than facilitates movement, condensation forming ice in critical areas, and moisture from breath or snow infiltrating mechanisms and freezing them solid. Allied armies in 1945 employed primarily bolt-action rifles for their infantry, with some semi-automatic weapons in American service, designs that had proven reliable in temperate conditions, but showed serious weaknesses when temperatures dropped below zero. The standard British Lee Enfield rifle used throughout Commonwealth forces was an excellent weapon in normal conditions, offering good accuracy and a smooth bolt action that allowed rapid fire by trained soldiers. American forces carried the M1 Garand semi-automatic rifle, a more advanced design that gave individual soldiers increased firepower, but relied on a complex gas-operated system with multiple moving parts. German forces used predominantly the Mauser Kar 9.8K bolt-action rifle, a design optimized for accuracy and reliability that had served through multiple conflicts. All these weapons shared a common vulnerability to extreme cold that manifested in similar ways across different designs: bolts that became difficult or impossible to operate as lubricants froze, magazines that failed to feed properly, firing pins that moved too slowly to reliably ignite primers, and condensation that formed ice in chambers and prevented proper seating of ammunition. The technical challenges of operating firearms in extreme cold had been understood in general terms by military establishments, but the practical solutions remained inadequate, as the brutal winter of 1945 demonstrated with deadly clarity. Standard military lubricants used on weapons were designed for temperate climates and became thick or solid at low temperatures, turning into glue that jammed mechanisms rather than allowing them to move freely. Training manuals offered guidance about winter weapon maintenance, but the advice often proved impractical in field conditions where soldiers lacked facilities for proper cleaning and lubrication, where any exposed metal would instantly freeze to bare skin on contact, and where the weapons needed to function immediately in combat rather than after careful preparation in controlled conditions. Soldiers across all Allied armies learned through bitter experience that weapons carefully maintained and functioning perfectly in rear areas would often fail within minutes of exposure to combat. Conditions where breath condensation, snow infiltration, and handling by cold-numbed hands created ice buildup that stopped mechanisms from cycling. The result was a winter battlefield where rifle companies found significant percentages of their weapons non-functional at critical moments, where machine gun crews struggled to clear stoppages caused by frozen parts, and where the basic individual weapon that soldiers depended on for survival became unreliable precisely when needed most. The question that German intelligence officers began asking as they compiled reports from units facing Canadian forces during winter operations centered on a troubling observation that contradicted their understanding of how cold weather affected combat effectiveness. Why did Canadian infantry maintain substantially higher rates of fire than other Allied troops in identical temperature conditions? What techniques or modifications allowed them to keep weapons functioning when American and British soldiers in adjacent sectors reported widespread equipment failures? The reports from frontline units were consistent enough to rule out coincidence or isolated incidents, describing encounters where Canadian troops sustained automatic and semi-automatic fire in conditions where German experience suggested most weapons should have frozen into uselessness. Some German observers speculated about secret lubricants or weapon modifications that Canadian forces possessed, while others wondered if the Canadians had developed entirely new firearms specifically designed for Arctic conditions. The reality proved simultaneously simpler and more complex than these theories, rooted not in technological breakthroughs, but in fundamental differences in how Canadian forces understood cold weather equipment operation, trained their soldiers, and approached the problem of maintaining combat effectiveness in extreme environments. The story of how Canadian troops kept firing with frozen triggers reveals patterns that extended far beyond firearms maintenance to encompass a comprehensive approach to winter warfare that gave them decisive advantages over enemies and allies alike. The preparation of Canadian forces for winter warfare began long before deployment to Europe, rooted in a national experience with extreme cold that shaped military thinking from the earliest stages of training and equipment development. Canada's geography encompassed vast regions where winter temperatures routinely reached levels that European or American soldiers encountered only during the most extreme weather events, creating a population base where substantial numbers of recruits had personal experience with cold that could kill the unprepared within hours, and where equipment failure meant genuine life-or-death consequences. Military trainers recognized early in the war that this experiential knowledge represented a strategic asset if properly leveraged, and they structured training programs to build on existing, cold weather competence while adding military-specific skills and techniques. The approach to weapons training in winter conditions reflected this philosophy, moving beyond the standard manual of arms to address the practical realities of operating firearms in extreme cold through methods that seemed unorthodox to observers accustomed to conventional military training. The fundamental problem with firearms in extreme cold stems from the interaction between metal, lubricants, moisture, and the mechanical requirements of weapon systems that must move precisely and repeatedly under combat stress. Conventional military wisdom addressed this through careful maintenance and liberal application of lubricants designed to reduce friction and protect metal surfaces from corrosion, an approach that worked adequately in temperate conditions but failed catastrophically when temperatures dropped below freezing. Canadian weapons instructors taught a counterintuitive solution that violated standard, military practice, and horrified traditional armorers when they first encountered it: remove virtually all lubricant from weapons intended for use in extreme cold. The logic was simple once explained, but required understanding of how cold affected materials. Lubricants that facilitated movement in warm conditions became impediments in cold as they thickened into sticky substances that increased rather than decreased friction. A weapon, stripped of excess lubricant and operated essentially dry, would function more reliably in extreme cold than one properly lubricated, according to standard procedures. The metal-on-metal friction that would cause rapid wear in normal conditions, proving less problematic than frozen lubricant jamming mechanisms. The training regime for Canadian infantry emphasized hands-on experience with weapons in actual cold conditions rather than classroom instruction about theoretical principles. Soldiers spending hours on winter ranges learning how their rifles behaved at different temperatures and what techniques kept them functional when conventional approaches failed. They learned to recognize the warning signs of ice buildup before it caused complete failure, the slight resistance in bolt movement or trigger pull that indicated moisture was freezing in critical areas. They practiced immediate action drills for clearing cold weather stoppages that differed from standard malfunction clearance. techniques that addressed ice accumulation rather than mechanical failures or ammunition problems. They learned unconventional methods for keeping weapons at temperatures that prevented ice formation while still remaining ready for immediate use, such as carrying rifles under outer layers of clothing where body heat prevented freezing, a practice that seemed unmilitary but proved far more effective than conventional weapons carriage in extreme cold. The training created muscle memory and instinctive responses that allowed soldiers to maintain weapons functionality under combat stress in conditions where stopping to think through procedures could prove fatal. The weapons themselves underwent modifications that reflected Canadian understanding of cold weather requirements, changes that were often subtle but collectively significant in maintaining reliability. Trigger mechanisms were altered to reduce pull weight, making them easier to operate with cold-numbed fingers, or while wearing gloves thick enough to provide protection against frostbite. Sights were modified or selected to remain visible in snow conditions and to function when covered with frost or ice. Slings were adjusted for use while wearing heavy winter clothing that added bulk and changed how weapons were carried and brought into firing position. Metal surfaces that soldiers needed to touch were wrapped or covered with materials that prevented the instant frostbite that occurred when bare skin contacted frozen metal. Modifications that looked unmilitary but prevented casualties from cold injury. Perhaps most importantly, Canadian units were issued with weapons cleaning equipment specifically designed for field use in extreme cold, including scrapers and brushes that could remove ice buildup and cloths that would not freeze solid when wet, allowing soldiers to perform maintenance under conditions where conventional cleaning equipment became useless. The doctrine that emerged from this training and equipment development emphasized maintaining weapons functionality as an active, continuous process rather than a state achieved through proper initial preparation and periodic maintenance. Soldiers learned to constantly monitor their weapons for ice accumulation and address it before it became critical, using body heat to thaw components when necessary, scraping ice from mechanisms during lulls in combat, and adjusting their handling techniques based on current temperature and conditions. They learned that in extreme cold, a weapon could go from fully functional to completely jammed within minutes if not properly managed, but that with correct techniques it could remain operational for extended periods in conditions that would render conventionally maintained weapons useless. This approach required vigilance and created additional task loading for soldiers already dealing with the numerous challenges of winter combat, but it produced forces that maintained their firepower when others lost it, providing decisive tactical advantages in engagements where the side that could sustain effective fire often won regardless of other factors. The German snipers and infantry who faced Canadian troops during the winter of 1945 were encountering the results of this comprehensive system, soldiers whose weapons kept firing, not through superior technology or secret modifications, but through superior understanding of cold weather realities and thorough training in techniques that maintained functionality under extreme privates conditions. The Reichswald forest in February 1945 presented one of the most challenging combat environments of the entire war, a densely wooded area along the German-Dutch border, where trees and terrain channeled movement into predictable paths, and where German defenders had constructed layered defensive positions designed to extract maximum casualties from attacking forces. The weather added another dimension of difficulty with temperatures well below freezing, snow covering the ground, and conditions that turned routine military operations into struggles against environment as much as enemy. Canadian forces tasked with clearing the forest found themselves fighting in close-quarters conditions where engagements occurred at ranges measured in tens of meters rather than hundreds, where automatic weapons and sustained fire proved far more valuable than marksmanship, and where any hesitation or weapon malfunction could prove immediately fatal. It was precisely the sort of environment where cold weather weapon failures would have the most severe tactical consequences, and it was here that the Canadian advantages in maintaining weapons functionality under extreme conditions proved decisive. The fighting developed into a nightmarish progression through frozen forest where visibility was limited by trees and terrain, where German machine gun positions covered every approach, and where progress was measured in meters per hour rather than kilometers per day. Canadian infantry moved through this environment in small groups, using fire and movement tactics that required weapons to function on demand as soldiers alternated between advancing and providing covering fire for their comrades. The intensity of close-quarters combat meant that individual weapon reliability affected not just the soldier carrying it, but the survival of entire squads who depended on sustained suppressive fire to move without being cut down by German defenders. In these conditions, the Canadian training and weapons maintenance practices demonstrated their value through the simple but crucial fact that rifles and machine guns continued to fire when needed. Soldiers bringing weapons from cold external temperatures into firing positions, and finding that triggers responded, and actions cycled despite conditions that would have rendered conventionally maintained weapons inoperable. German defenders fighting from prepared positions initially held advantages in fields of fire and protection, but they quickly discovered that their own weapons were succumbing to cold at rates that undermined their defensive effectiveness. Machine gun crews found that belt-fed weapons, which should have dominated approaches, were jamming after short bursts as ice formed in feed mechanisms and receivers, requiring time-consuming clearance procedures that left positions vulnerable. Riflemen discovered that bolt actions that had worked perfectly in rear areas were freezing in the open position or requiring force to close that made rapid fire impossible, reducing their effective rate of fire to a fraction of normal levels. The Mauser rifles that equipped most German infantry were excellent weapons in principle, but they were maintained according to standard military procedures, with lubricants appropriate for temperate conditions, and they were suffering the same cold weather failures that affected other conventionally maintained firearms. The result was a defensive force whose firepower was being degraded by environmental factors beyond their control, fighting an enemy whose weapons continued to function despite identical conditions. The tactical impact of this firepower differential became apparent in engagement after engagement as Canadian forces pressed forward through the forest. German positions that should have been able to stop attacks through sheer weight of defensive fire found themselves unable to sustain the necessary rates of fire, machine guns jamming at critical moments and riflemen struggling with weapons that refused to operate properly. Canadian assault groups approaching these positions maintained suppressive fire that forced defenders to remain under cover, automatic weapons and rifles firing sustained bursts that would have been impossible if the weapons had been failing at rates similar to those affecting German forces. The attackers were able to close distances that should have been killing zones precisely because they could keep firing while defenders could not, a reversal of the normal dynamics where defensive positions held inherent advantages. German soldiers attempting to surrender found that even this carried risks in close-quarters combat, where the chaos and violence made distinguishing genuine surrender from tactical deception nearly impossible, and where Canadian troops maintaining aggressive fire often killed defenders before surrender could be communicated or accepted. The psychological impact on German defenders proved as significant as the tactical advantages Canadian firepower superiority provided. Soldiers fighting from positions that should have been strong found their weapons betraying them at critical moments, creating a sense of helplessness and vulnerability that undermined morale and will to resist. They were facing an enemy that seemed immune to the environmental factors that were degrading their own combat effectiveness, troops whose weapons worked when theirs failed, and who pressed attacks with a confidence born of knowing their equipment would function when needed. The reports that filtered back through German command channels described encounters where Canadian troops sustained fire in conditions where such performance should have been impossible, creating an impression of technical superiority or special equipment that added to the general sense that facing Canadian forces was particularly dangerous. The reality was more prosaic but no less effective. Simple maintenance practices and thorough training allowing Canadian soldiers to keep fighting when others could not, translating into tactical advantages that accumulated across individual engagements into operational success. The frozen triggers that German snipers and infantry expected to see on Canadian weapons simply did not materialize because those weapons were being maintained and operated according to principles that prevented such failures, giving Canadian forces a decisive edge in winter combat that enemies could observe but not explain or counter without understanding the underlying approach to cold weather warfare. The medical records and after-action reports compiled during and after winter campaigns provided quantifiable evidence of how weapon reliability affected combat outcomes beyond simple tactical success or failure. Canadian units fighting in extreme cold conditions reported weapon malfunction rates dramatically lower than those of Allied formations in comparable environments, differences that translated directly into DEWES, combat effectiveness and casualty rates. When infantry weapons function reliably, soldiers can suppress enemy fire, maneuver under covering fire, and respond immediately to threats, capabilities that become compromised when significant percentages of weapons in a unit are non-functional at any given time. The data showed that Canadian formations maintained these capabilities in conditions where other units saw their effective firepower reduced by weapon failures to levels that made offensive operations extremely costly or impossible, providing advantages that commanders exploited to achieve objectives that might otherwise have required far greater force or proven unattainable. The German military establishment undertook analysis of Canadian weapons and maintenance practices after capturing equipment and interrogating prisoners, seeking to understand the techniques that produce such superior cold weather performance. The findings surprised intelligence officers who had expected to discover technological innovations or sophisticated modifications, but instead found weapons that were essentially standard-issue items, maintained according to principles that violated conventional military practice. The removal of most lubricants from weapons intended for extreme cold use shocked German armorers who had been trained that proper weapons maintenance required liberal lubrication to protect mechanisms and ensure smooth operation. The Canadian approach of essentially running weapons dry in cold conditions seemed reckless and likely to cause accelerated wear and potential failures, yet the evidence clearly demonstrated superior functionality in the field conditions where performance actually mattered. Some German units attempted to adopt similar practices based on this intelligence, but the changes came too late in the war to significantly affect outcomes, and institutional resistance from weapons specialists who considered the approach unsound limited implementation. The comparative analysis extended beyond simple weapon functionality to encompass the broader approach to cold weather combat that Canadian training and doctrine emphasized. The recognition that extreme cold required active, continuous management of equipment rather than passive reliance on proper initial preparation represented a fundamental shift in thinking that affected everything from how soldiers carried weapons to how they conducted maintenance during combat operations. This approach imposed additional cognitive and physical demands on soldiers who were already dealing with the numerous stresses of winter combat, but it produced forces that retained capabilities others lost when environmental conditions became extreme. The willingness to accept practices that looked unmilitary or violated established procedures when field experience demonstrated their effectiveness reflected organizational flexibility that proved valuable across multiple domains beyond just firearms maintenance. The human cost of weapon failures in combat provided the most compelling argument for why Canadian approaches deserved serious attention, regardless of how unorthodox they might appear to traditional military thinking. Soldiers who found their weapons jammed at critical moments faced death or capture because they could not defend themselves or support their comrades, individual tragedies that accumulated into unit-level casualties and mission failures. The winter campaigns of 1945 saw numerous instances across Allied armies where attacks stalled or defensive positions were overrun because weapon failures degraded combat power below levels necessary to accomplish missions or hold ground. Canadian forces were not immune to these problems, but they experienced them at significantly lower rates, maintaining effectiveness that made them disproportionately valuable for winter operations and leading to their repeated commitment to the most demanding missions. The soldiers whose lives were saved because their weapons fired when needed could not know the specific counterfactual of what would have happened with different maintenance practices, but the aggregate statistics across thousands of engagements painted a clear picture of how equipment reliability affected survival and success. The institutional lessons that military establishments drew from winter warfare experiences during World War II influenced cold weather doctrine for decades afterward, with Canadian approaches to weapons maintenance in extreme cold becoming standard practice across NATO forces and widely studied by militaries operating in Arctic and mountain environments. The recognition that maintaining combat effectiveness in extreme conditions required not just proper equipment but also appropriate maintenance practices and thorough training represented a shift away from purely technological solutions toward more holistic approaches that considered human factors and organizational culture. The frozen triggers that never materialized on Canadian weapons during the winter of 1945 stood as testament to the value of grounding military practice in genuine understanding of environmental challenges, rather than theoretical principles or conventional wisdom, a lesson that remained relevant in subsequent conflicts where environmental factors continued to challenge forces that failed to adequately prepare for conditions they would face. The Nazi snipers who expressed their stunned bewilderment at Canadian troops who kept firing in conditions that should have rendered weapons useless had witnessed the practical application of these principles, encountering an enemy whose preparation and doctrine gave them advantages that could not be overcome through superior marksmanship or tactical positioning alone. The legacy of Canadian winter weapons practices extends beyond military history to encompass broader questions about how organizations identify and adopt effective solutions to challenging problems. The fact that superior approaches to cold weather weapons maintenance came not from advanced research laboratories or weapons manufacturers, but from practical experience and indigenous knowledge, reflects patterns that recur across multiple domains where genuine expertise often resides in unexpected places. Military establishments are necessarily conservative institutions that value proven procedures and standardization, qualities that serve important purposes in maintaining discipline and ensuring consistent performance across large organizations. But this conservatism can become an obstacle to effectiveness when it prevents recognition of better approaches simply because they violate established norms or come from non-traditional sources, creating situations where institutional resistance to change perpetuates inferior practices despite clear evidence of alternatives. The individuals who developed and implemented Canadian winter weapons doctrine were not celebrated inventors or high-ranking officers, but rather experienced soldiers, trainers, and Northern Canadians who understood cold weather realities through lived experience rather than theoretical study. Their contributions to military effectiveness during World War II saved lives and achieved tactical successes that influenced the war's outcome in measurable, if not always quantifiable ways, yet their names remain largely unknown, and their methods were initially dismissed by establishments that valued conventional expertise over practical knowledge. The eventual acceptance of their approaches came only after overwhelming field evidence made resistance impossible, suggesting that similar valuable innovations might be delayed or lost entirely when evidence accumulates more slowly, or comes from sources that lack credibility within organizational hierarchies. The question of how military and civilian institutions can remain open to innovation while maintaining necessary discipline and standards continues to challenge organizational theorists and leaders across multiple domains. The soldiers who fought through the winter of 1945 with weapons that continued to function when others failed carried memories of specific moments when reliable firearms made the difference between survival and death, instances too numerous and personal to fully capture in historical analysis, but collectively constituting the human reality underlying statistical differences in weapon malfunction rates. A rifleman who could return fire immediately when ambushed, rather than struggling with a frozen bolt. A machine gunner whose weapon continued firing when German positions should have been cutting down his squad. A soldier whose rifle worked when he needed it to defend a position against counterattack. These individual experiences aggregated into the collective capability that German observers found so remarkable and troubling. The confidence that came from knowing weapons would function when needed affected morale and aggressiveness in ways that extended beyond the tactical advantages reliable firearms provided, creating forces that approached winter combat with assurance rather than apprehension about whether their equipment would work. The post-war careers of veterans who had served in Canadian winter combat units often included roles as trainers, advisors, and technical consultants, where their experiential knowledge remained valuable for decades after the war ended. Some found themselves teaching new generations of soldiers heading to Korea, where winter conditions would again test military effectiveness and equipment reliability, passing on lessons learned in European forests and Dutch lowlands to troops who would face similar challenges in Asian mountains. Others contributed to development of improved cold weather equipment and doctrine, as military establishments worked to institutionalize wartime lessons and prepare for potential Arctic operations during the Cold War. The knowledge they carried represented both individual expertise and collective organizational learning, wisdom that could be transferred through training and doctrine, but that was most effectively conveyed through direct instruction by those who had learned it through combat experience. The frozen triggers that Nazi snipers expected to see but never encountered on Canadian weapons during the brutal winter of 1945 symbolize a broader truth about military effectiveness and organizational learning that transcends the specific historical context. Success in extreme environments requires more than just good equipment or brave soldiers. It demands appropriate doctrine, thorough training, and willingness to adopt practices that work regardless of whether they conform to established norms or satisfy aesthetic preferences about how military organizations should operate. The Canadian troops who kept firing when conditions should have rendered their weapons useless were not superhuman or equipped with secret technology, but simply soldiers who had been properly prepared for the environment they would face and who applied that preparation with the discipline and skill that thorough training develops. Their story stands as testament to the value of grounding military practice in genuine understanding of challenges, rather than assumptions or conventional wisdom, and to the importance of remaining open to innovation, even when it comes from unexpected sources or violates established procedures. The lessons remain relevant in contemporary contexts, where complex challenges continue to demand solutions that may look unconventional but prove effective when properly implemented and applied, reminding us that expertise and innovation can emerge from any source when necessity demands and organizations remain willing to recognize value regardless of where it originates.